This last one you're doing is going to show you the brilliance of a scientist. A person who sits, thinks, and thinks, then comes up with something that will give us an important solution. Such an important solution. This was a game-changing move, I tell you. This was a game-changing move because it is what helps us. Say we go into a lab, we want 1 mole of sodium. We can know what mass of sodium to get. We can be able to get a certain mass of sodium. And we know that when I have, say, 25 grams of sodium, I now have 1 mole. Okay, I didn't say 25 grams is the one that leads, but we can actually know to say when I get this mass of sodium, I will have 1 mole of sodium. So it's like if a scientist wants 2 moles of sodium, or 2 moles of sodium chloride, rather, let's say 2 moles of sodium chloride, our table salt, or 4 moles or 1 mole of sodium, or 0.5 moles of sodium chloride, they can be able to know what mass, because we will be having sodium chloride, that's just salt, the table salt. Fine granules, it's a solid, because our ionic compounds we are solids, right? They have a very high melting point, very high boiling point. So in other words, when they have a very high melting point, when at room temperature, the normal temperature, they are going to be solid. So now we can know what part, how much mass to measure, and then we can be able to know what volume, if you have a liquid, to put for you to have 1 mole. This is amazing. This is amazing. And do you know how they did it? Let's find out. It's through this guy called molar mass. So molar mass is just the last part. They had thought it through from the word go when they designed that U, the atomic mass unit. It's a special invention because that U was designed carefully. It has a special link. And what link does it have? Now, here is the idea. We are now looking at what we call molar mass. We looked at the atomic mass, we looked at the molecular mass, we looked at the formula mass. And formula mass is the mass of one formula unit, like NaCl or MgCl2. We'll be looking at ionic compounds, right? I hope you guys will have no doubt whatsoever when it comes to those things. Now, when you talk about molar mass, it is the mass in grams. So now we are not using U. This is the only guy which does not use U for mass. Wow. It is the mass in grams of 1 mole of a substance. Okay? And it is expressed as grams per mole. In other words, the grams per mole. How many grams you have for 1 mole of that guy? Because it has to be grams per mole. We can't just say grams. We have to be now dealing with large quantities for us to be able to get the mass in grams. Because remember, one atom has useless mass. No mass at all. 1.66 times 10 to the negative 24. Now you say 0.0000 like 23 or 24 times, like 23 times. Come on. That's a very small value. In grams, that is nothing. But now we can be able to get a significant mass. We are actually now dealing with big masses where we can measure on our scale. And for us to be able to get mass in grams, we have to look at 1 mole of a guy, 1 mole of a substance. And what is 1 mole? When we say we have 1 mole of something, we'll be having 6.02 times 10 to the 23 particles. These particles could be ions, they could be atoms, they could be molecules, they could be what do we say? They could be formula units. Now, what is it that so whatever you have, so it's like an NaCl, this is a formula unit, right? We have 26.02 times 10 to the 23 of these. We'll be saying we have 1 mole of NaCl. Okay, we didn't say 1 molecule. No, please don't think 1 mole is 1 molecule. No, 1 mole is 6.02 times 10 to the 23 particles. This is called Avogadro's number. So 1 mole is equal to Avogadro's number of things. Okay, Avogadro's constant of things. If you have 6.02 times 10 to the 23, you have 1 mole. Now, if we have 6.02 times 10 to the 23 sodium atoms, we can be able to find that mass of those guys in grams because there are now so many. And do you know how we find their mass in grams? Do you know the mass of 6.02 times 10 to the 23 sodiums? What is the mass of this? 6.02 times 10 to the 23 sodiums. You want to know their mass? Just go and look at the mass of a sodium atom in use. The mass of a sodium atom in atomic mass units. That value is going to be the mass of 1 mole in grams. So 1 atom in U will give you the same as 1 mole in grams. So if we say, so molar mass is very easy. You don't have to look for it. It's there on the periodic table. But the only difference is on the periodic table, we were getting the mass. Let's say if it was for sodium, it's 1 sodium atom. Now, if we want 1 sodium mole, if we want 1 mole of sodium atoms, like 6.02 times 10 to the 23 atoms of sodium, what mass do they have? We can know it in grams. We just take that value and we write it as grams. That is the answer. So when they made atomic mass units, it was so perfect that the mass of something in of 1 atom in atomic mass units is the same as the mass of 1 mole of that guy. And the mass of 1 molecule of water, if we look at 1 molecule of water, H2O, we said if we want to get that mass, we use atomic mass units because these are just 3 atoms. And we coded the molecular mass. So we can go and take the molecular mass of water. We saw the molecular mass of water. We say 2 times the mass of hydrogen plus the mass of oxygen. We got the answer, 18 point blah, blah, blah. If we now have 6.02 times 10 to the 23 waters, we can get that mass in grams. We just go and take that value in grams and that will be the mass. So it will be 18 point blah, blah, blah grams. If you calculate, you're going to find this answer. So here's the statement that is important. It says that the molar mass has the same numerical value as the atomic mass, molecular mass, or formula mass. If you can understand this part, we can close the session right now, this video. Molar mass, if we are looking at atoms, if you are looking at sodium, what is the molar mass of sodium? Just go and look at the atomic mass of sodium and write that answer in grams. That will be the molar mass. That will be grams per mole. We'll be either saying 1 mole of sodium, we have this mass in grams. That's why we say grams per mole. Now, what about molecular mass? Molecular mass, we know that it is for molecules like H2O. This here would have our molecular mass. Okay? These are... Now, what do you say to me? How would you get the mass of H2O in grams, of 1 mole of H2O? Well, if you can just go and get the mass of 1 mole, you write the mass of H2O in atomic mass units. We had it in atomic mass units. If you forgot, just go and check. We took 2 hydrogens and they were in atomic mass units, 2 hydrogen atoms, then we added to 1 oxygen atom, we found their mass. For 1 mole of that, you just change it to grams and it'll be that same answer. Easy, right? Great. So the only thing that changes is you now have grams and not atomic mass units. It's the same for formula mass. Formula mass would be for things like MgCl2. We saw the mass of MgCl2 when we coded the formula mass. Now, if you want the molar mass means 1 mole. Mass of 1 mole of that guy. So 1 mole of MgCl2, its mass will be in grams. And we go just by changing U to grams. An example, carbon, which is an atom, has an atomic mass of 12 units. So if we ask you, 1 carbon atom, 1, that's the atomic mass. We say the atomic mass is the mass of 1 atom. Now, what is the molar mass of carbon? There we go, 12 grams. We just take the same value and we put it to grams. And it's going to be true. That is how good this U is, man. It makes it easy. When you want to convert to grams, when you want to get the mass of 1 mole, you just convert that mass to the unit to grams, and you'll be done. 1 water molecule has a mass of 18.015 U. To get 1 mole of water molecules is just going to be 18.015 grams. Grams, the same, but you put it in grams. That'll be the mass of 1 mole. Sodium chloride had a formula mass of 58.44 units. And how did we get it? We got the mass of sodium plus the mass of chlorine, right? And we got 1 sodium chloride formula mass. It came from NaCl. Now, do you know what? We can be able to get 1 mole of sodium chloride. We know what its mass would be. It will be 58.44 grams. That will be 1 mole. It will be now in grams. So we can come from atomic mass units to grams. Yes, as long as we are talking about 1 mole. As long as we are talking about 1 mole, we just change from atomic mass units to grams. It's going to be just like that. Really? Yes, just like that. Look at how easy this is. And now we'll be having the molar mass. So sometimes you see them say sodium is going to be equal to 58.44 grams per mole. This means that 1 mole of sodium is going to be 58.44 grams. Okay? And that is the molar mass. We change it to grams when we are dealing with moles, because moles are huge. We now have a lot of atoms, so we can actually put them on a scale and we can actually measure them and get their mass in grams, because there will be so many now. Okay, that is the idea, and this is how easy it is. I hope you understood this part, and see you in the next videos. Bye.